Hey class, today we are in section 12-2 of your book and we're dealing with matrix multiplication. Our objective is to multiply matrices using scales and matrix multiplication. Okay, just a little bit of vocabulary. Multiplication of a matrix A, remember A will be the name of that matrix, by scale factor C is scalar multiplication. To find the resulting matrix CA, so that's C times A, you multiply each element of A by C. And there's an example of it on page 81 of your book. So in our first example, we have A and B, and we are asked to find what is 4A plus 3B. So first we need to find 4A. So that's 4 times the matrix A. So 4A would be 4 times 2, 4 times 8, 4 times negative 3, 4 times negative 1, 4 times 5, and 4 times 2. Oops. Okay, that would then give us 8, 32, negative 12, negative 4, because remember that's negative 1, 20, and 8. All right, to do 3B, this time I'm just going to write the answers. 3B would be 3 times every element of B, so that would give us negative 3, 0, 15, 0, 9, and 6. All right, finally we are to add those two matrices together. So 4A plus 3B. So 8 plus a negative 3, right? 8 plus negative 3 would be 5. 32 plus 0 is 32. Negative 12 plus 15 is 3. Negative 4 plus 0 is negative 4. 20 plus 9 is 29. And finally, 8 plus 6 is 14. So this matrix is our final answer. In try number 1, we're using the same matrices from the previous example to solve. So just to remind ourselves of what those matrices are, A was 2, 8, negative 3, negative 1, 5, 2. And B is negative 1, 0, 5, 0, 3, 2. All right, so to multiply, so 3A, we multiply 3 times every element of A, so 3 times 2 is 6, 3 times 8 is 24, 3 times negative 3 is negative 9, 3 times negative 1 is negative 3, 3 times 5 is 15, and 3 times 2 is 6. Minus 2B, so 2B would be 2 times negative 1 is negative 2, 2 times 0 is 0, 2 times 5 is 10, 2 times 0 is 0, 2 times 3 is 6, and 2 times 2 is 4. So remember, we are subtracting these numbers to get our final answer down here. So 6 minus a negative 2, right? That minus and then the negative here will actually make this 6 plus 2. So 6 plus 2 is 8. 24 minus 0 is 24. Negative 9 minus 10 is negative 19. Negative 3 minus 0 is negative 3. 15 minus 6 is 9. And 6 minus 4 is 2. So here's our final answer at the bottom. In example 2, now we're asked to solve using matrix multiplication. So essentially what we're looking at is an equation, for example, that's like 2x plus 3 times whatever number, let's say 4, equals some number, and let's say 5, right? So we would, in this case, order of operations would tell us to multiply first. Then we would subtract 12. And then we would divide by 2 to get our final answer. So that's essentially the same exact thing we're going to do, except we have matrices. So let me get rid of this. Let's go ahead and do that. Okay, so the first thing we need to do is multiply. So 2x plus 3 times everything in that matrix, which will be 6, negative 3, 9, and 12. And we have 8, 5, 11, and 0. Okay, now we need to subtract that matrix on both sides. So I'm just going to subtract 6, negative 3, 9, and 12 from 6, negative, and actually I don't want to put that below. I'd rather put that beside it. So minus 6, negative 3, 9, and 12. And I'm only doing this because this is kind of the pattern that we're used to seeing for a subtraction. So here, those are gone, and we're left with 2x is equal to whatever this new matrix is. So the new matrix is 8 minus 6 is 2. 5 minus a negative 3, remember that changes it to a positive 3. So 5 plus 3 now is 8. 11 minus 9 is 2, and 0 minus 12 is negative 12. And the last thing we need to do is divide by 2. So divide this by 2, divide that, that, and that. So x will equal 1, 4, 1, and negative 6. That's our final answer for example 2. All right, so we're going to try that again with try 2. So again, we need to multiply first. So we have 3x. And this time we're multiplying by negative 2. So this becomes, and you know what? I'm actually going to say, well, you can say negative 2. So if you multiply by negative 2, then technically you're adding now. So let's multiply negative 2 to everything. So in other words, this is just like distributive property. So negative 2 times negative 1 is 2. Negative 2 times 5 is negative 10. Negative 2 times 7 is negative 14. And negative 2 times 0 is 0. All right, now we're going to subtract those matrices over. And actually this time I won't have the space to do it horizontally, so I'm still just going to subtract it. That's gone, and I'm left with 3x equal to whatever our answer is going to be. So 17. So 17 minus 2 is 15. Negative 13 minus a negative 10, that becomes positive. So now that's negative 13 plus 10 is negative 3. Negative 7 minus a negative 14, that double negative makes that a positive. So this is now 7. And 0 minus 0 is just 0. Okay, finally we need to divide by 3. So x is going to be equal to 5, negative 1, 7/3, and 0. All right, so in example 3, we are multiplying matrices. To be able to multiply matrices, the quick and easy way to multiply matrices is to multiply using a calculator. I've already showed you all in class how to set up matrices into the edit section of your calculator. So what you will do is set up an A, set up a B matrix, and then back on the home screen, you will multiply matrix A. So you'll do matrix A times matrix B and press enter. So if you do that, your answer for this one will be negative 2, 10, 3, negative 9. Again, that's negative 2, 10, 3, negative 9 is the answer to that matrix. So try it in your calculator and see if you can get that as your answer. In try 3, again, we're going to multiply. And again, we're just going to check to see if we get, this is our answer. So substitute, put these matrices into your calculator. And so your final answer should be, when you multiply, let's see, this is B times A. So that'll be negative 3, 7, 6, and 8. So that should be the answer to that particular matrix. All right, finally, we need to determine whether a product of matrices exists. Okay, so in the last example, we had two 2x2s. So we had a 2x2 multiplied by a 2x2, and they begot a 2x2. In this particular case, we have a 3x2 for the first one, and a 2 by 3. Okay, to determine whether products of a matrix, products of matrices exist, the two middle terms have to be the same. If they are the same, then you can multiply their matrices. If not, then you can't. So in this case, we can multiply A times B, but to multiply B times A, so for this one it's yes. For the second one, however, we have a 2 by 3 multiplied by a, we have a 2 by 3 multiplied by a 3 by 2, right? Because the B was 2 by 3 and the A is 3 by 2. And so once again, yes, this will work because their center dimensions are the same. All right, so here, again, the first thing you want to do is determine what type of matrix it is and then see if it'll work. So here we have a 2 by 2. And then the second example, we have a 1 by 2. Remember, it's rows by columns, rows by columns. So for an A times B, that's a 2 by 2 times a 1 by 2. Their center numbers are not the same, so no, that product does not exist. Okay, however, for the B, if we have a 1 by 2 multiplied by a 2 by 2, then yes, those products do exist. All right, guys, that's the end of our matrices section. If you have any questions, remember, just come see me for tutoring. Have a good one.